our Hadoop components are there. So how we are going to connect to the cluster through the PuTTY, and how we are able to access the cluster services through web browser, right? And what the Hadoop components which are available under Hadoop subproject, and how we are going to access those things through GUI. So that we have seen in yesterday session, right? So it's a small topic in chapters second chapter. So how to run a job in Hadoop, right? So before that, now we have discussed, like, so we have the different ways we are going to run the job, right? So that's the one thing is the data processing tools. Running a job means you have some input data is available in SDFS, and then you are going to write some queries or some programs on the Hadoop supported programming languages, right, by targeting the data which is available in SDFS. So that's mean to say that we are going to run a job, right? So what you have to remember here is, if you want to run a job in Hadoop, right, the running a job means it's a program, right? So whether you write this program in a Hive, or you're going to write this in a Pig, or you're going to write this in a Scoop, or it's a job scheduling in Uzi, right? Otherwise, you're importing the data from the RDBMS production database to the Hadoop cluster using a Scoop, right? So these are what we are doing is a job, right? So whatever it may be, right, wherever you're writing the jobs, the first thing is we should always has to make the data available in SDFS, right? So you are querying the data, or you're passing the data, right? So first thing is you should make the data available in SDFS. After that, to run the job, right? Now which job, so what the job you want to write, so you are looking for the data ingestion, importing the data from the production database, or collecting the data from the server, or you want to apply some analytics on the data, you want to do some processing on the data, right? It's a job, right? So that so this is one kind of job. Or you want to store the data into the database, or you want to generate some visualizations on the data. So we are going to run different types of jobs, right? So now whenever you are going to run a job, so what we need, so first thing is the data should be available in SDFS. Once the data is available in SDFS, then we are going to write a job. So this job is processed by the, either it can be a job tracker, okay, either it can be a job tracker and a task tracker, okay. So if you are using Hadoop before 2.0 or Hadoop after 2.0, right, so we are running this job on a map reduce. So when you're running the job on a map reduce, means we are going to start the job tracker, and we are going to have the task tracker. So then the job tracker will take the job from the client, and it will process, job tracker will process the data, and the job tracker will give the job to the task tracker, and the task tracker will execute the job. Then that task tracker will send the output back to the job tracker, the job tracker to the client. So this is if you are working with a map reduce. In Hadoop 2.0 onwards, we have YAR, right? So we have YAR. Now YAR, in the sense, what we have, instead of the job tracker, we have a resource manager is available, and instead of the task tracker, we have a node manager is available. Right now, you're running a job on Hadoop cluster where the cluster is enabled by the YAR, so that now the client request or the job which the user is supposed to execute is taken by the resource manager. In the resource manager, it will allocate the resources, as well as we have an application master will monitor the job, will process the job, and the job is executed in a node manager, in a data node. Node manager will execute the job, and it will give the output back to the resource application master. Application master will submit the output back to the client. That is, now here in Hadoop 2.0 onwards, if the cluster is enabled by the YAR, then we are running the job on the YAR. So when you're running the job on YAR, so we are going to work with the resource manager as well as node manager, right? So when the job is running, right, so we can check the job status. Suppose job tracker is there. Now you have wrote a job in Hive, or you wrote a job in a Peak, right? You wrote a job in a Scoop, or it can be some any job you're writing. So each job is given by the assigned a job ID. Job tracker will assign the job ID to the job, right? Once the job is taken by the job tracker, job ID is assigned to that job. Then it will split the data as possible. Now it will assign the number of mappers, number of reducers, and that job is going to process. Now we can able to see the status of the job, right? How much job is completed, right? So we have we can use a command. Hadoop job is a one command we are having. So with that one we can able to see the statistics of the job. Otherwise we have job tracker web UI is available, right? So job tracker web UI which is 50030, where we can able to see the information about the job. That's you can able to see how much job is created, how much job is completed, right? How many jobs are pending, and what the job configuration, job parameters, right? So everything will be specified in this job tracker web UI. Okay, so this is job when we are running a job on a map reduce, right? So the job is given, it's known as a job. The query request by the user or the client will be known as a job. The job is taken by the job tracker, and the job will be given a job ID, and we can able to check the status of the job with the Hadoop job command. And if you want to check through web UI, we can use the job tracker web UI to check the statistics or the status of the job and the job configurations and the job parameters used in that one. So we can able to see the complete information about that particular job. The same thing now that the task tracker is working, right? So we have the task tracker, how much the task is completed. So the statistics related to the task tracker, which is available on 50060, where we can able to see once the job is completed, then task tracker will flush its memory, so you won't find anything. Once the job is completed, again task tracker will be an empty, right? So while the job is executing, so in the task tracker will page, you will find that number of attempts that it is trying to run. Suppose first it will try to run the job, fine. If it is everything goes well, the task tracker completely execute the job and it will give the output back to the client. Suppose the task tracker is trying to execute the job, but the job is failed, right? It is unable to run the job, then it will attempt twice, then it will attempt thrice, right? After that it will it will try max 5 times. So based we have a maximum attempts is one configuration we have in mapred-site.xml. So it will try that number of times, right? Attempt 1, attempt 2, attempt 3, attempt 4, attempt 5, right? Even in attempt 5, if it is unable to proceed the job, it is unable to run the job, it is unable to execute the job, now it will be thrown as an error will be given to the user. So it will try 5 times, so that we can see the statistics about the task tracker, how it is running the job in a page task tracker web UI, which is available with 50060. We can open this in a browser, right? So this is when you're running with a job in a map reduce, right? Suppose if I want to run a job in a yarn enabled cluster, so now we don't have this job tracker and task tracker. So we'll have, instead of the job tracker, we'll have a resource manager and application master is available, right? So instead of the task tracker, we have a node manager is available. So what is the specialty in Hadoop 2.0, right? So here before 2.0, right, every job must be a MapReduce job. So in a Hadoop cluster, we should run a MapReduce job, and we cannot able to run any other job other than the MapReduce. But in Hadoop 2.0 onwards, we can able to run a MapReduce job, as well as we can able to run a non-MapReduce job. Okay, so in Hadoop 2.0 onwards, we can able to run a job which is a map reduce. And if you don't want to write the map reduce, yes, you don't write, then we have a yarn is available which supports non-map reduce jobs. Now here that the client request, right? So you write some program in Hive or Big Cube, right? It's a, here we are calling it as a job ID. Here we consider it as an application ID. So every program written by the user is known as an application. So each application will be taken along with the application ID. It's same thing. It's a like job ID. Here we are having an application ID. So the status of the job executing, right? How much job is created, how much job is completed, what are the job configurations are there. So we have yarn cluster is available on port number 8088. So if you connect it through 8088, then we can able to see the job statistics, where we are going to run the job in a resource by the resource manager, by the node manager, that's a which a yarn enabled cluster. Right, so the job statistics we can check, we can see in a web UI with the port number 8088. Right, so now, so this is now running a job in Hadoop new environment. So the recent versions almost we are enabled with the yarn. But certain times I just want to run the job in a MapReduce. I don't want to go with a yarn. I'm having Hadoop new version right now. I'm working with Hadoop 2.6.0. Okay, so right, it's by default yarn enabled cluster. But now the job which I'm going to write, which should be a MapReduce job, I don't want to run that in a yarn. Yes, it's possible we can able to run a job as a MapReduce job in a yarn enabled cluster. I'll repeat, we can able to run a MapReduce job in a yarn enabled cluster. So your job wants to be a MapReduce? Yes. Your job want to be a yarn, run on yarn? Yes, we can do the both the things. But here before 2.0 the job must be a MapReduce job. We cannot write a yarn here. But in Hadoop 2.0 onwards, if you want to run a job with a job tracker and task tracker, yes, you can able to run. Or if you want to run a job with a resource manager, node manager, yes, you can able to run. So here you have to start the yarn, then the job is executed in yarn. Otherwise, if you want to run the job with the MapReduce, yes, so we have a property that's MapReduce.framework dot something local is there. So if you write a classic, if you specify the property is a classic, then the job executed in a MapReduce mode. If you run it is a yarn, then the job executes in a yarn cluster. Right, so now we can, it's up to your choice whether you want to run this job in a MapReduce or in a yarn. Okay, so now in the Hadoop 2.6.0, right, where the by default it is enabled by the yarn, but I want to run a job with a MapReduce. Yes, we can able to run the job. So in a configuration file, MapReduce-xml, if you specify MapReduce.framework.local equal to classic, then the job is executed by the MapReduce. Okay, so now, right, so this is running a job in before 2.0 and after 2.0. Now we'll see, I'm going to the Hadoop environment. Okay, so now see here Hadoop is not available, right? So if you write Hadoop space version, right, so here I'm using Hadoop 2.0.0 is available, where CDH 4.0.0 I'm using. So there is no Hadoop is available now. So if you run Hadoop space fs ls, right, it's trying to connect to the server, but it's failed. So now let me start Hadoop in the cluster. Okay, so I have the scripts are available in CD trainings. ls, I'm going to my, it's a my CD scripts. Right, here I'm having start cdh.sh is a script which is used to start the Hadoop in this cluster. Right, so now you want to start yarn, or you want to start with a job tracker and task tracker. Right, suppose see here I'm running sh space start hyphen cdh dot sh. I'm running the command cdh space start sh space start cdh dot sh. Okay, so now I'm going to start the SDFS in the cluster. SDFS means now only the name node, secondary name node are available, data nodes are available. Okay, now see, I have started this. To check what are the process running, we can run a command jps, which is a Java process state. Write the jps and press enter. right now. So in my cluster right now, name node is available, secondary name node is available, data node is available. Means, so in this cluster now SDFS is started, so there is no map reduce available, there is no yarn is available, right? So you can check this, open a browser. Now try to open name node with the 50070. Yes, it's available. Try to open job tracker 50030. So if you try to open 50030, right, so there is no task, job tracker is started here. So if suppose you are trying to start a cluster with a yarn, right, we have not started the yarn. Right now, I'm going to show you how to start yarn in this cluster. Okay, so that is, I'm going to run a job on yarn. Okay, so we'll take simple steps now, how to start yarn. Okay, so now that is, you have to start the yarn. So to start the yarn means what are the yarn dimensions? We have to start the resource manager and we have to start the node manager. So if the both the processes are started, means the cluster is enabled and yarn is running, so that we can able to run the job. That is, if you want to start the yarn, you have to start the resource manager, then you have to start the node manager. Right, to start the resource manager, I have a command is available. I'm going to, right, so my Hadoop home cd trainings, just clear the screen. So if you type yarn, press enter. Okay, so I want to start the yarn. So now write the yarn space, press enter. Now, so these are the commands which are available with yarn. So now to start the yarn resource manager, now we can use yarn space resource manager to run the resource manager. You can give yarn space node manager to run the node manager and node manager on each data node. Right, so now I'm going to start the resource manager first. So I'm going to take a terminal. So here, run the command yarn space resource manager space start. Right, now I have started the resource manager, and which is running in this cluster. Okay, so now resource manager is started. Okay, now I'm taking on the terminal to start the node manager. So to start the node manager, so what is the command? If you don't remember the command, then you have to write yarn, press enter, then it will show you the possible command that comes with yarn. Okay, so just press type yarn, press enter. Now we have yarn and node manager is available, right? So to start it, write yarn space node manager space start. Okay, so now in this cluster, in this terminal, resource manager, we can see here we can see the node manager, right? So I have started the resource manager and have started the node manager. That means in a cluster now I have started the yarn. To check that what are the Hadoop daemons running in this machine, now run the command jps. Right, see now we have resource manager is available and node manager is available. Right, in the previous run we have only the node manager, and sorry, we have name node, data nodes, and second names, name nodes are available. After that, manually I have started the resource manager and node manager. So now in this cluster I can able to run the job. Right, now we'll see this. So previously what we did, when I'm trying to start the yarn, it did throw the error, right? So unable to connect. Now refresh it, I have started the yarn. Now I can able to check the status of the cluster, information about the cluster. Now click on refresh it. Right, see, right, so the cluster is running on the port number 8088. Now where we can able to see the information about the cluster. Right click here, about, right? So now, so this is the information about the cluster. So is there any applications are running right now? So there is no application is running in this machine, right? So this is a cluster ID. So when it is started, so information about the cluster and how many nodes are there, right? Where it is configured, we can able to see the information about the data nodes in this cluster, right? So that's I have opened this in a browser with a port number 8088. Okay, now let me run a job. Okay, so I'm taking a terminal now. Okay, I'm just running a program, right? Some Hive query. Okay, so now take a terminal and to start the Hive, right? Hive is a SQL kind of programming, right? Where we are going to process the data, right? It's similar like MySQL. So I'm going to Hive. Okay, so now I'm in Hive terminal, right? So if you want to see the tables, just write show tables. If any tables are there, it will list the table names, right? So there are some tables are available here. Okay, so I'll take some prod info. Let me see what we have. Select start from prod info, right? It's an empty table. Let me check some. Okay, right, so I'm having some table new test, right? So I want to run a job now. So what I'll do, it's a map reduce job, so that is some count is involved. I want to count the number of rows or the number of records in the table new test. So I'm writing now select space count of star from the table name new test. Now see here, Hive will identify which query is require a map reduce, which query doesn't require a map reduce. Suppose in the previous, when you run select start from new test, it has to only display the data from this new test, so there is no map reduce job is involved. But now in the second, I'm going to run count, right? I just want to count the number of rows in this table, right? So I run count star. For this, it needs a map radius, right? It needs some parsing. Okay, so now this job is taken by the yard. Now I press the enter. Now see here, number of job is running in the node manager is working with the job. Now we can see here, right? It's an attempt ID, right? Job is processed to the resource manager and job is executed in a node manager. If you open the browser in the applications window, now see, this is the job which we are running. Select count start from new stage. Okay. Now see, this is the where Hive terminal where I wrote the query. Then the jobs taken by the resource manager and processed through the node manager, and we can able to see the statistics here. Okay. So let me run again. Let me find out some other table. Run show tables. Okay, so I have a table. Now I'm running the query. Select count of start. So this job is taken by the Gartner job, right? So taken processed by the resource manager. Now see, select count to start from the table name user pages semicolon, press enter. Once you press the enter. First, the job is taken by the resource manager and it will be processed to the application master, and job can be executed by the node manager. Now we can see clearly, observe here. I have opened the 4 windows now. Okay, so this is a Hive terminal. So this is a resource manager, and this is a node manager, and this is a browser statistics. Now I'm pressing the enter. So press enter. Now refresh it. So now resource manager and node manager processing this job. Now see here the application details. Now if you click here, we can able to see the application details. Okay, so in this way we run a job in Hadoop, right? So the job statistics will be available here. Okay, so this is the application, right? So whenever I wrote a program, I wrote a query that will be processed as an application, and that will be assigned as an application ID, and that status of that application we can able to see in the cluster apps page, right? So if you click on this link, now we can see the who is the user execute the job and what is the job it is. So the state of the job, right? So final status and when the start job is started. And if you want to see the job history, right, click on history, right? So I think it's we doesn't have the history server, so I'll start the history server. If you write map rate, press enter, then map rate space history. Right, so I've started a job history server. So job history server is a some daemon which will store the job history, right? So job configurations, right, everything will be monitored through the job history server. Right, now we can able to see the job statistics, right? Number of mappers, number of reducers, right? So the job history can be displayed with the job history server, right? So this is running a job in a Hadoop cluster where the cluster is enabled by the yarn. Okay, so see here where we have the data cd documents ls. Now I have created a file. The file name is mobiles, right? So where it is, cat mobiles, right? So we have some records are there. Now I want to load this data into the Hive, right? So just simply create a table in Hive. So how we create a table in Hive, just I'm going to show you like how we have Hive program and how we have Peak program, right? It's a one suppose if you want to create a table in Hive, where we in Hive we always create the tables. So you can create a table, so then write mobiles. So what we have, the name of the mobile we are having, so which is a type of string, right? So we have something, right? Let me check this, right? stc is used by Ajay, and now see I'll take Nokia is used by Tahir, and iPhone it's by Chris, Samsung Rajendra, right? So we have some data is there, right? Username and mobile name. So each field is separated by the tab. That is, it's a mobile name, then a tab and username. Okay, means we have the two fields in input data, each field separated by the tab. So I'm going to create a table in Hive. create table. I'm writing table name mobiles. So what is the first field? Mobile name is a string data type, comma username, which data type it is? String. Okay, fine, we have specified the fields. Now what are the delimiters in input data, right? So each field is separated by the tab. This is important, right? In Hadoop we have to specify the delimiters, right? How your input data fields are separated. So to specify that, we write a one sentence, row format delimited. So I am specifying that my input data is delimited with some delimiters. So just write row format delimited. Okay, and each fields terminated by, what is the delimiter? Slash t. So I'm going to write slash t. Okay, semicolon, right? We'll discuss about this complete syntax and Hive programming in Hive session, right? So today I'm just going to show you how we have Hive program, right? The intention of this example is to show you, right, how a Hive program looks like, how we are going to create the tables and how we are going to retrieve the data, how we are going to load the data into the table, and how we are going to run a job. It's a small demo session on Hive. That's it. Okay, so the complete Hive will discuss in Hive session, right? The table is created. Now it's an empty table. You can see select start from mobiles, empty table. If you want to see the structure or schema of the table, then you can write describe mobiles. Okay, so we have the two fields. Now I have to load the data from the local file system. So local file system, in the sense, now it is available in my documents. So I'm going to write one statement, load data which is available in local file system, which is in path. Which path? Where my data is available in the documents, right? So that is, if you write pwd, so in home Hadoop documents I'm having a file mobiles. So now write the same path here, load data local in path home Hadoop documents and have a file mobiles, right? I want to load this into a Hive table. Just write into table mobiles. Right now from this local file system, from my documents, now the data is loaded into the Hive table. Now we can see select start from mobiles. Okay, so in this way we have loaded the data into Hive table, right? So if you want to run some job, simply you can write select count of star from mobiles. Right, so the job can be monitored through the page Nodemanager and ResourceManager, right? So there are 11 records are there. Now if you open the browser, we can able to see the statistics. Click on the jobs. So 8088. Okay, so this is the job. Select count star from the mobiles. Click on this application ID. Now the job is finished successfully, and you can see the job history. If you click on this history, now you will see the complete job history and the job parameters. Right, so this is how we are going to write a program in Hive. So what you observed here, so the most of the Hive code is similar like MySQL program. So we have create the table, then from the local file system in my documents I have loaded the data into Hive table. After that we can write Hive queries to process the data. Okay, so exit. Okay, suppose if you want to write the program in pig, so then we'll write something pig-x local to start the pick. So it's a pick environment grant. Now take the mobiles equal to, I have to load the data, right? From where? Load home. My data is available in home Hadoop documents, I have a file, mobiles, right? So what is the delimiter here? We'll write using peak storage is used to specify the delimiter. So the delimiter is a slash t. Okay, as so username. So first one is a mobile name. Which type it is? It's a here with string, right? So in peak, string will be taken as a char array. Mobile is a char array, comma uname is a char array. So this is how a peak program looks like. Okay, so what I did, simply first I have took one relation, mobiles equal to, in this variable I want to load the data from the file mobiles. So I wrote a statement, load space, and from where you want to load the data, write the file name. And this file mobiles contains input data separated by or delimited by the delimiter tab. So that I wrote with using peak storage. Peak storage is a function which specifies how your input data is how the fields in input data is separated, right? What are the delimiters in input data? So my file, so each file is separated by the delimiter tab. So that I wrote in peak storage using peak storage, the delimiter slash t as. So I have the two fields. One is a mobile, which is a character array, and username is a character array. So write it, press enter. Now to see the output, what we stored in the mobiles, so just write dump space mobiles. To stop the yarn, to stop the resource manager, then write yarn space resource manager, then write stop, press enter. Now I'm going to stop the resource manager. Now to start the node manager, then write your yarn space node manager space stop. Okay, so now I have stopped the resource manager and I have stopped the node manager. So there is no right yarn as well as MapReduce running in this cluster. Now suppose if you want to try to run a yarn hive query, it won't work because we need MapReduce, we need either job tracker or a resource manager to run the job. So if you hit here clear, suppose go hive, and if you write select, write some job count of star, else. Now can we able to run this job? No, because there is no job tracker as well as there is no resource manager or node manager is available to process job. Now the job is initiated, but who will process the job? So if you have the job tracker, we can able to start it. If we don't have the job tracker or the resource manager, we cannot able to run this job, right? So it's, I think it's not completely closed. Okay, so resource manager exit. Now node manager is trying to connect, it will be exited now. Okay, let me run this job now. Right now we cannot see this 8088 because we have stopped it. Right, so do we have, yeah, 8088 cluster is running? No, there is no yarn is running in the cluster, so we can't able to see the yarn information here. Right, even see the job is also not executed because there is no job tracker as well as there is no yarn is available. You can check with the command jps. If you run the command jps, right, so here name node, secondary name node, or data node, right, only these three diamonds are running. So there is no job tracker as well as there is no task tracker, there is no yarn is running. So that means there is no map redis, there is no yarn, that is we can't able to run a job. Now see, I wrote a Hive query, it threw the error. So first the job is initiated and the job execution is failed because it's unable to find the yarn as well as it's unable to find the job tracker in this cluster. But when we are working in a real time, right, so the cluster is started, it is running from over the years, so we don't start and stop this manually. Okay, so here I'm going to show you how to start and stop, right? But the thing is what, when you're working on the cluster, so it is running over the year, so generally we don't get the chance to completely stop the cluster. So when we start and stop, if you are going for some maintenance mode, then only we'll go with some maintenance mode by stopping it. Otherwise, if the cluster is job tracker or at the particular node where these daemons are running, if it is unavailable, so to make this up and run, first we close it, we stop it, then we'll troubleshoot it, then we'll make up and run. So only these are the situations. But right now in the newest version, suppose if you are using Hadoop from the cloud era or you are using Hadoop from the Hortonworks, right, so by default, when you start the cluster, it will start all the Hadoop as well SDFS as well as MapReduce daemons. We no need to start and stop these daemons, right? So I have given Hadoop environment to you on yesterday, right? So in this one, you no need to start. By default, if you start Hadoop in the cluster, if you start the CDH4, by default, it runs a script and it will start all the job tracker like a MapReduce as well as SDFS will be started, right? So we no need to run these scripts every time. Okay, now see, I have started. So you can check with the command jps what are the processes are running in this machine. Jps, press enter. Right now see here, name node, node manager, job history server, resource manager, secondary name node, data node, right? So all the Hadoop daemons and yarn are running in this cluster now.